Here is the question. A3B2 is a sparingly soluble salt of molar mass m gram per mole, and solubility is given x gram per liter. The ratio of the molar concentration of B3 minus to the solubility product of the salt is. So this we have to find this two product. One is the concentration of B3 minus, and second is the solubility product of this salt. So if you divide it, we will have to get these equations. So we can solve these equations. So let us start with this A3B3. This is only salt. A3B2 is the salt. This is sparingly soluble, and you know this saltage which is very less soluble in water, that is called a sparingly soluble salt. So this then it will split into again A. So we can see here. So this is the A. So 3 molecules of A, and this is 2 minus, and this will be 2 molecules of, not 2 ions of B with 3 minus, and their solubility is given x gram. So we'll take here x. So this is 3x, okay, and this is your 2x gram per liter. So if you divide it by capital M, this becomes concentration. So 2x by m, and this becomes your 3x by m. So if you see the KSP value of this one, so KSP value will be equal to so we can multiply 3x by m to the whole power 3, and 2x by m to the whole power 2. This is the solubility product of the salt. The question being asked is, what is the concentration of B3 minus, and divide by what is the concentration of salt. Salt is A3B2 product. So B3 minus is given how much? It is given here 2x divided by m, and down is given here, if you solve it, so this becomes your 3 cube. So 3 cube is 27 x by m whole cube. This is the one product, and next is 4. So this becomes your 4 into x square by m square. So if you solve it here, so on solving you will get this is your 3 plus 2 5 minus 4. So you will get here m4, and divide by this will be your 2. So it will be 54 into and then multiplied by x4. So this is our answer. So we check carefully in which of the options are correct, and so we can see the option C is correct. This one only correct. All three are wrong answer.